Hi, so in this video, what we're going to do is we're going to look at differentiating the hyperbolic cosine function. So if you saw the last video that I did, we looked at differentiating the hyperbolic sine function. And what we found is that when you did that, you got the hyperbolic cosine function itself. So this time what we want to do is differentiate this hyperbolic cosine function. So again, there were kind of two definitions that you could use when defining these hyperbolic functions. So again, I'll write out the hyperbolic sine definitions first. So you could either use this half e to the x take away e to the negative x as a definition, or you could use this complex variables definition. So negative I sine of ix. And for the hyperbolic cosine function, I'm just going to put of x in there just so we know we're working in x as a variable. So again, with the hyperbolic cosine function, again, two definitions we could use. So this definition in exponentials, so e to the x plus e to the negative x, or the complex variable definition, so just cos I times x. So so again, what we're going to do when differentiating the COSH function is we're going to use both definitions. So definition number one, definition number two, and we're going to prove the result that we get basically and work that out. Okay, so when we differentiate COSH using the first definition, so the exponential definition, so COSH by definition is a half of e to the x plus e to the negative x. And so therefore we've got this constant a half. We can just bring that outside the differentiation. So we've got d by dx, so half times d by dx of this e to the x. Again, differentiation is a linear operator, so we can just actually differentiate each part separately, so that part and that part. So we're going to do d by dx of e to the x and d by dx of e to the negative x. So similarly to like what we did in the last video with differentiating these exponentials in terms of the sinh or the shine or the hyperbolic sine function. So it's just the same kind of process. So we differentiate e to the x with respect to x. Well, we just get e to the x again because that's the exponential function. And with this second differentiation, so again, kind of the chain rule. So you want to differentiate the negative x. That's just going to get you a negative 1. And then multiply that by the derivative of e to the negative x with respect to e. Sorry, let me say that again. The derivative of e to the x. Sorry, let me say that again. The derivative of e to the negative x with respect to negative x. Well, that's just going to be e to the negative x because the exponential function stays the same under differentiation. So you've got negative 1 times by e to the negative x. It's just that. And again, if we go back to our definition list, this thing that we got there is exactly the same as this thing there, which is one of the definitions of this hyperbolic sine function. So yeah, so this there is exactly hyperbolic sine of x. And yeah, so therefore we can conclude down here. Sorry, I'll do this on a new page. So we know that d by dx cosh x is actually just hyperbolic sine of x. Yeah, so when we differentiate hyperbolic sine, we get cosh. When we differentiate cosh, we get hyperbolic sine. So yeah, no negatives involved with this differentiation example. But again, similarly to what I did in the last video, I'm now going to use the second definition as well to show that when we differentiate this, we get that over there. So let's do that. So differentiating cosh by definition is the same as differentiating cos of ix. And again, so we want to do a little bit of chain rule. So we want to differentiate this function inside the cos. So differentiating a constant times by x is just a constant. So we're going to get I and then we want to differentiate cos of ix with respect to ix using the chain rule. So that, again, when we differentiate cos, we get negative sine. So that's going to be negative sine of ix. And so just simplifying the negatives, we get negative I sine ix. And again, as we expect, if we look at our exponential definition of sine of a hyperbolic sine, that is just the same as that. And so this is by definition hyperbolic sine. And so again, we get the same result as over here. So differentiating hyperbolic cos gets you hyperbolic sine. So now what we know then is that, yeah, so when you differentiate sinh or sine or hyperbolic sine, you get COSH. When you differentiate hyperbolic cos, you get hyperbolic sine. And so let's just pretend we're going to put negatives here. So you want to differentiate negative hyperbolic sine or negative hyperbolic cos. Well, you're just going to put the negatives there and there as well, because -1 is just a constant, and that doesn't really affect the differentiation apart from multiplying your final answer by that constant. So yeah, if there were minus signs in front of the sinh or the COSH, you just put minus signs in front of the answer. So yeah, so this is a little bit more simple actually than differentiating normal sine and normal cos, because yeah, when you differentiate sinh, you get COSH. When you differentiate COSH, you get sinh.